So I'm Todd Barrett. I'm the director of the strategy team in OIT infrastructure. We're the people who run servers, storage, networks. We run multimedia. We run a lot of the things you don't think about until there's a problem with it. So for that reason, I hope we haven't been on your mind a lot lately. We're going to talk about cloud computing today and kind of what it is, what resources we have available on campus, and actually this presentation will be a little different. I want to tell you what we've got, and then over the upcoming days and weeks, I'd like you to come talk with us about how you can better use that. So, oh, my clicker may not work up here. All right, well, let me step down and stand at the podium here. So cloud computing, first of all, let's start talking about what is not cloud computing. Cloud computing isn't a way that we reduce bugs in our software. Oh, thank you. It doesn't reduce any bugs in our software. It doesn't bring any additional moisture, even to dry email, and it's not something we should really fear. Cloud computing is the delivery of computing as a service rather than as a product. It's more like a utility, and it's delivered over a network typically. This definition comes from Wikipedia, which we talked about a little bit earlier this morning, as a cloud service encyclopedia. Compare that with the digital encyclopedias from 10 years ago, the Microsoft Encartas. Every year they rolled out a new version of Encarta. Every year you bought a new set of disks, and when you wanted to find something, you'd search through this catalog. Wikipedia is the opposite of that. They have one catalog stored in their data center. We don't even have to know where their data center is. We don't have to know anything about their servers to be able to use Wikipedia. All we know is their website address, and that somehow we'll get the data we're looking for. That's what we call a cloud application. We use cloud applications all of the time. I think many of us are probably even using some of these sitting in this auditorium right now. These are different applications where our data, we don't even know where it goes when we put it in. Is it going, what state it's in most of the time? But what if we could take this a step further? Instead of an application we're interacting with, what if we could actually deliver computers as a service over the internet? And we can, through a process we call virtualization. It's a technology we use. To best explain it, I realize we don't have all technical computer people in the room, so let's talk in terms of an analogy here. We have, in this picture, oh, that's a mouse. Let's try this laser here. Too much technology here. We have a server with an operating system installed on it. We call this a platform. So this would be like if I walk into Best Buy and buy a computer, I get a piece of hardware and it has an operating system, and the two are pretty well joined together. On top of that, we install applications. It might be Microsoft Office, it might be a game we want to play, but the application gets installed on top of our platform there. Let's liken that to a car and a young man who drives it. That car is his vehicle to get to work, it's his vehicle for entertainment, he uses it in the evenings when he wants to go places. But largely that car sits underutilized. It's parked at home when he's asleep. It's parked at work when he's at work. These servers actually are very much the same way. People aren't running servers at 100% utilization all of the time. That's too much. You'd want to expand out. So servers sit largely underutilized, which means higher power bills. It means we're buying a lot of resources we aren't actually using. So we have a tendency to scale things out. This young man's scaling out his family. He's now added another person in his car there. We add other applications to our platforms that we're running. This works great much of the time. We run into conflicts sharing cars. Sometimes we don't like the same radio stations, or we like Windows up or Windows down. We run into all these things. Applications do the same thing sitting on a server. They may not play as well together as we'd like. So now we've scaled out to make better use of these resources. And now we go ahead and we put each application on its own platform, creating more of a problem with our efficient use of resources. We've now compounded that problem by adding another platform that we're running this on. As we start expanding out more and adding more and more applications, we get less and less efficient by building out more servers. This is where the concept of virtualization comes in. Oh, we can try a carpool model here where we stack up our platform with all different applications, just like we put all kinds of people in this ultra reliable Volkswagen bus here. But anyone who's driven one of these knows that there are times when it goes down, and if that's your carpool vehicle, you've got 5 irritated people sitting with you. Same thing happens in the server world. So a solution, the efficiency and an effective model here is we go to a public transportation system model. Here, it's not the vehicle we're driving that's the real benefit. It's the operations and the logistics of the public transportation system. We've virtualized it, so you don't ride a bus by knowing the bus driver's name or even the license plate number of the bus. You ride a bus because there's a published schedule of here's where the bus will be and at what time. They've virtualized the fee. The bus driver doesn't ask for gas money or for maintenance costs when you get on the bus. It's all virtualized into that bus ticket that you buy. This scales very well. This will deliver to far more people than 1 or 2 servers or than 1 or 2 cars will. This is a virtualized model for transportation. The individual car would be the physical, or we refer to them as physical servers or discrete server model. The same happens in our data centers. OIT has purchased large racks of these are blade servers depicted here. Each one of these is capable of running a massive amount of applications at once. It's a whole lot of buses here waiting to be utilized. Through the process of virtualization, we carve out these resources. Resources we talk about in terms of gigabytes of memory, terabytes of storage, and compute cycles, gigahertz of compute cycles. We carve this into what we refer to as clouds. There's no operating system installed. It's simply capacity. We deliver this capacity to the administrator of this cloud. We have many of the academic units on campus are using this, and many of the administrative units are using this product. We deliver to them pure raw capacity. We haven't determined what operating systems they're running. We haven't determined what applications they're running. And then each of those administrators goes through and installs, builds the platforms he wants inside of this cloud. Very scalable because we don't draw definite lines. You can make a server as big as your entire cloud, or you can make 100 small servers depending on how you want to chop up that allocation. You can bring new resources in dynamically. On the back end, we can now take much better utilization with each of these blades because we can load up each server so that it's running close to its capacity, so that it's running right where we want it to be. When we need to do maintenance on servers, we simply move things to another server, and we can take down servers without the users ever knowing that we're even moving things around. This helps us be much more tolerant of hardware failures or upgrades. We can do upgrades without impacting the services that are really running. So this is something that we'd like to offer, and we'd like to know how you want to use this. This is our product. As you're working with your account managers and as you're talking with our product managers, this is our Brigham Young University Y Cloud. We're looking to expand this. I'd love to see this in the next upcoming years be used as a teaching resources. How can faculty and students utilize this? What if you could have a server ready to go instead of the weeks it takes to order one, have it delivered, and install an operating system? What if it was a matter of minutes and you had a server there ready for you to use for your research project or a student project they're working on? What if this was something where classes needed server resources and just enrolling in the class made it so that you had those resources available to you? You sign up for a class and a server is automatically delivered to you that you can then utilize in your schoolwork. The possibilities for this are really endless, and we're looking to you to help us know how this would best meet your needs. So I probably can't take a lot of questions right now, but here's my contact info, and I would love you to pull me aside afterwards. We have product managers who support different parts of this, and we'd love to know how you want to use this and how this can help enhance your teaching and learning in the classrooms.